this video, we're going to multiply some rational expressions. We're going to start off with just monomials, those single-term polynomials. And all we do is ask ourselves, is there anything or any factors on top that are also living on the bottom? And if there is, we need to divide them or cancel them out. So I first see that both 24 and 36 are even, and I can see that there's numbers that go into both of them. In my mind, 6 pops out, so I'm just going to divide a 6 out of both. Maybe you took out a 2 or a 12. The goal is to get the biggest number, but if you miss it, I want to show you that it doesn't matter. So when I divide a 6 out of the top and a 6 out of the bottom, I'll get 4 over 6. Those are both still even. So all I need to do is take another bite out. I'm going to bite out or divide out a 2, bite out or divide out a 2, and that'll leave me with a 2 over a 3. Now I know I kind of got that part of it completely simplified. I also see that there's x's on the top and x's on the bottom. So I'm going to divide an x out of the top and the bottom. And that'll leave 1 up there on top. The only thing I haven't considered is that 25. And I see that it ends in a 5 and so does 35. So I'll just divide them each by 5. 35 divided by 5 is 7. Now that I think I'm done, I'm going to go look at all the stuff that's left on the top and on the bottom. I'm just going to double check that I still can't divide anything out top to bottom. We never divide out across. And I can't. I also have to make sure I don't forget about that negative out front because that never canceled off. Once we're pretty sure that everything's canceled as much as it can be, we multiply straight across. 2 times 5 is 10, and then I have the x, and then I have the negative up on top. All over, when I multiply on the bottom, 3 times 7 is 21. I always take a quick glance at it before I think I'm done, and I ask myself, can anything be divided out of 10 and 21? And the answer is no, so I circle it and move on. So in the second example, we won't deal with monomials. We're going to deal with when you have to factor first. So here's number 19, the last one on the worksheet. And what we need to do is ask ourselves 2 questions when we factor. We ask ourselves, can I take anything out or divide anything out? And is it a quadratic? So for the top left, can I take anything out of m and 1? No. Is it a quadratic or to the second degree? No. So I'm going to move on to the top right. Can I divide anything out? Well, yes, because they're both even. But furthermore, there's a bigger number. There's an 8 that I can pull out or divide out of both of those. Then I go to the bottom left. Is there a common term that I can divide out? Yes. 3 lives in both of those. So I just pull it outside. It's undistributive property. I divide it out. Now when I go over to the bottom right, I notice there's nothing that I can divide out of each term. But it is a quadratic. So I have to think about trying to factor this by that method that we sometimes call unfoiling. I don't have to worry about the front terms because only m times m equals m squared. But I do need to go look at this last term because there's 2 pairs of numbers that multiply to equal 10. 10 and 1 or 5 and 2. How do we decide which one? Well, back to chapter 8, we look at that middle term and we know that whatever we pick has to add up to -9. There's no way that's happening with 5 and 2, but 10 and 1 I can get a -9 out of. Not if I leave them both positive, because those add up to 11. But if I make that 10 negative, now I got my pair. Those multiply to equal -10 and add up to -9. So let's go remove those arrows and factor that into our m minus 10 times m plus 1. Now that I'm confident that I've factored everything, I'm just going to start canceling. M plus 1 on the top, m plus 1 on the bottom. M minus 10 on the top, m minus 10 on the bottom. Nothing else cancels. So we just rewrite it, multiply across, and that's how we get that answer of 8 over 3 times m minus 5, because that's what's left.